Hello, welcome back once again. Today we have this infinite nested radical involving root of 4s, and surprisingly we have 4 plus here, and here we have 4 minus. Here we have 4 plus, and here we have 4 minus. The question here is, how can we find the exact value of this infinite nested radical? Now let's get into the video. Okay, now please, if you're new here, kindly subscribe, turn on the notification bell so that you'll be notified anytime I upload new video. Thank you for watching. Now let's get into this video. Here we're going to start with a substitution. First of all, we're going to let x equals the one which we are seeing here, root of 4 plus root of 4 minus root of 4 plus, and so on, right? And from here we're going to also let y equals root of, this time around it will be 4 minus root of 4 plus root of 4 minus, and so on. Okay, now from the first equation here, that is our equation 1, here we have our equation 2. From equation 1, let us square both sides. So we get x squared equals root of 4 plus root of 4 minus root of 4 plus, and so on, then squared. And from equation 2, let us square both sides. We'll get y squared equals here root of 4 minus here root of 4 plus here root of 4 minus, and so on. And we square this. Okay, so from here, from this equation 1 right over here, we have x squared equals, remember this square will cancel this first root sign here, and we are left with 4 plus root of 4 minus root of 4 plus, and so on. And from this equation 2 right over here, y squared will be equal to, here, this cancel this first root sign, and we're left with 4 minus root of 4 plus root of 4 minus, and so on. Okay, so from here, this implies that x squared equals 4 plus, here, take note of this, that this is exactly equal to y, right? So we have y here. And from this equation 2, this implies that here, y squared equals here, that is 4 minus, here, this is exactly equal to x, right? Take a look at it at the equation 1 there. That is root 4 plus root of 4 minus, and so on. That is x, right? So here, this is equal to x. Okay, so what do we do from here? What exactly are we going to do from here? Now, from this equation right over here, let us move this y to the left. And when you do that, we get x squared minus y equals 4, right? And this equation right over here, let's move this x to the left. Remember, it is negative, so it will become positive. So we have y squared plus x equals 4. Okay, now there's something very interesting here. Remember, we have this equation, that is the left hand side of this equation equals 4, and here this one is also equal to 4. So this is actually telling us that y squared plus x will be equal to x squared minus y, right? So from here, let's move this term here, these two terms here to the left. So we get y squared plus x, the signs will change, that will be negative x squared then plus y, this equals 0. So from here, we're going to factorize. So how do we factorize this? First of all, here we have y squared minus x squared, then here plus x plus y, this will be equal to 0. This is the difference of two squares, right? Which we can factorize as y minus x and as y plus x, which is the same as x plus y, right? And here, what do we do? Are we making mistake? Okay, now this place right over here, we have x squared minus y here, right? Yes, okay. So here we have y squared plus x equals 4. And from here, okay, there's no mistake. So, and here now we have to add x plus y, right? But there will be a 1 outside. Is that true? Yes. So then this will be equal to 0. Okay. Now from here, x plus y is common, so we factor it out. X plus y, then into bracket, this will be y minus x, then plus 1, then this will be equal to 0. Okay, now let us recall back. As we know, x must be greater than 0. Also, y must be greater than 0. Therefore, if x is greater than 0 and y is greater than 0, this actually tells us that their sum will also be greater than 0, right? So this is very important to consider here. Then let's go back. Okay, so from here, we have that x plus y is equal to 0. We also have that y minus x plus 1 is equal to 0, right? So here we have x equals negative y, but if you take a very good look at this place, you see that their sum equals 0 here, but according to the above statement, the sum must be greater than 0. Therefore, we don't necessarily need this, right? Okay, so from here, if we move this y, this one right over here to the right, this will be y minus x equals negative 1. Multiply both sides by negative 1. The signs here we switch. That will be x minus y will be equal to 1. Sum of x and y, if it is greater than 0, then if x is greater than y, then x minus y will also be greater than 0, right? So therefore, we're going to make use of this right from here. Okay, so what do we do? Remember, from here we can actually solve for x or solve for y. Should we solve for y? Yes. So y will be equal to x minus 1. Okay. So now let us recall back that x squared equals 4 plus y. And from here, y equals x minus y. So we're going to substitute. So we get here x squared equals 4 plus, instead of y, that will become x minus y, 1. So here we have x squared equals 4 minus 1 here is 3. So we get 3 plus x. So from here, x squared minus x minus 3, this equals 0. So here we're going to use the general quadratic formula. So remember that here a will be equal to the coefficient of the leading term, which is x squared, and that is 1. And b will be the coefficient of x here, which is negative 1. And c, our constant here, is negative 3. So here x is going to be equal to negative b plus or minus square root of b squared minus 4ac divided by 2a. And this equals negative b will be negative in bracket minus 1, which is 1. Then plus or minus square root of b squared, in this case, will be negative 1 squared, which is 1, minus 4 times a, which is 4, times negative 3, which is negative 12, and 1 minus 12 will be 1 plus 12, and that will give us 13 right over here, then divided by 2. So from here, we can see that x equals 1 plus root of 13 divided by 2, or 1 minus root of 13 divided by 2. but this value here is negative. Remember that x must be greater than 0, and therefore here we come up with the solution that x equals 1 plus root 13 divided by 2, and therefore we cannot say that this infinite nested radical square root of 4 plus square root of 4 minus square root of 4 plus and so on equals 1 plus root of 13 divided by 2. And this is the right answer. Thank you for watching. Please kindly subscribe to my channel. Also like, comment and share. Bye bye.